Hello guys, this is Professor Oscar here. Today we'll be talking about rainbows. In order to study how rainbows are formed, first we must talk about a concept we call dispersion. What is dispersion? When we talked about refraction last time, we said that if the light travels from air to water, the direction of the light will change. This is because the traveling speed of light in air and water is different. But even for the same medium, such as water, the speed of different colors of light is also different. Therefore, the degree of deflection is also different. We found out that red light is deflected less strongly, while purple light is deflected more. Deflection refers to the difference between the new direction of traveling of light and the original direction of traveling. The original direction of traveling should be in this direction, but the deflection of purple is stronger and the deflection of red is not so strong. Then the order is red, orange, yellow, green, blue, indigo and violet. We call this phenomenon dispersion. Newton was the first to study the phenomenon of dispersion and concluded that white light is composed of 7 colors of light. Everyone knows how Newton discovered it with a triangular prism. When a beam of white light is traveling through the prism, the degree of deflection is different during the traveling process. The deflection of purple light is the most, while that of the red light is the least. So after it comes out, you see and you use a light screen to capture it, a rainbow appears. And you can see red light on top and purple light at the bottom. So this is basically the principle of rainbows. But if we observe more carefully, rainbows are actually divided into 2 types. The first is called a primary rainbow, which is red on the outside and purple on the inside. The second type is called the secondary rainbow, which is purple on the outside and red on the inside. Generally speaking, the primary and secondary rainbows appear at the same time, but secondary rainbows are relatively weaker in light intensity. So what we mainly see is the primary rainbow without the secondary rainbow. Then let's talk about the principles behind primary rainbow first. It's because the light enters the water droplets in the air for 2 refractions and 1 reflection. What does it mean? Okay, here is a drop of water. When light comes in, it's refracted and deflected for the first time, and then reflected, and then deflected again after the refraction. But for the same color of light, they are deflected, some color of light, they are deflected more. So the degree of deflection may be like this. Now let's think about these 2 light beams. The upper light is more deflected, right? So what color should it be? Purple. The bottom light deflection is not so strong, so it should be red. So if we have many water droplets in the air arranged in this way, then when the light passes through, you'll find that the purple light is more horizontal when it comes out, and the red light is more vertical. So when light comes in, it's refracted, reflected, and refracted. Let's see which one is more horizontal. It's purple, right? So we find that when we observe here, we will see that the bottom light beam is purple, and the light beam above is more vertical, right? So it's red. Therefore, we can see an arc with red on the outside and purple on the inside. This arc is a primary rainbow. Then there's the secondary rainbow. The secondary rainbow has 1 more reflection than the primary rainbow. It has 2 reflections and 2 refractions. What does it mean? Meaning the incident light is refracted once, reflected once, and then reflected again, and finally refracted out. That's 2 refractions and 2 reflections. Some light are deflected more, so they should be something like this. We will find that the more deflected light is the purple light, and the less deflected light is the red light. This time, the red light is more horizontal, and the purple light is more vertical. The exact opposite of a primary rainbow. So if there's a whole bunch of water droplets arranged and light beam enters, what will happen? After the light comes in, it's being refracted twice and reflected twice. In the end, which ray is more vertical? The top one is more vertical. Which kind of light is more vertical? The purple light. So we'll see the purple light on the outside. And which light is more horizontal? The red light. And this time we'll find out that secondary rainbow is purple at the outside and red on the inside. This is different from a primary rainbow that red is on the outside and purple is in the inside. Under normal circumstances, the secondary rainbow should be at a higher position than the primary rainbow. That is to say, they both exist at the same time. However, since the secondary rainbow is too high in position, it would be too faint for us to observe sometimes. That's why you can only see a primary rainbow at most times. Well, great, that's all for today. If you like my channel, please accent the like button, follow my Instagram account, subscribe and turn on the notification bell. And I'll see your beautiful face next time. Bye!